Hello everybody, how are you all doing? This is Vaibhav Singh and I wish you a very good morning, afternoon or evening from wherever you are watching this video at whatever time. So the purpose of this video is to share a web application that I developed recently for a webinar. The purpose of this application is to perform backups in a LAN environment, though it can definitely be configured for performing backups in whatever sort of network, be it internet or whatever you can think of. But basically, in this web application, I've implemented it for the use in a LAN environment. And the purpose of the app, which is also precisely called the backup app, is to run backups in a LAN. So what it precisely does is it comprises of three main components. First, the backup management web application, which is the UI part of it, which is the management console. And the backups can be scheduled, monitored, and all those sorts of things using the UI part. The second part is the REST API, which actually services the API calls, REST-based calls to and from the front-end client. And the backup agent, which is supposed to be installed on the computers or clients on which the backups are supposed to run. So pretty simple and straightforward. It's a pretty simple web application. However, the structure and the development design for the app is of an enterprise level. That is what precisely it's supposed to demonstrate, how an enterprise level web application is supposed to be designed and implemented. So the technologies used in developing this app are as follows. First, ASP.NET MVC5, WebAPI 2, AngularJS, Unity IOC or inversion of control container, Entity Framework 6, repository layer. So I'm including some design patterns also in this list. Code first POCOs or plain old CLR objects. So we're using code first for the ORM, and code first migrations for schema modification updates to the Entity Framework. .NET 4.5 asynchronous APIs, DDD or domain-driven design, and unit tests for both the WebAPI and the AngularJS part of it. So please enjoy the video and the demonstration and let me know your feedback or comments in the comment section, and I will definitely welcome it, try to implement it in my future work. So thank you all guys, please enjoy the demonstration. Thanks.
So good morning everybody and greetings for the day. My name is Vaibhav Singh and I'm currently working as a software engineer with one of the electronics company here in Copenhagen, Denmark. The purpose of this video is to explain the architecture, design and working of a backup application which is accompanied here with. The basic purpose of which is to configure, manage and run backups in a LAN-based environment. So without any further ado, let's dive straight in. So given the limited time, I did not create a very detailed and descriptive high-level diagram, but there is a simple outline of the components which should help us understand how the components are actually located and how they're working together. So let me open this real quick. Here in the diagram we can see we basically have two main components. First is a REST API and second is something called an agent. Now let's first focus on the REST API. REST API is literally the core of the application overall. It's responsible for the management, configuration, and even scheduling the backups in the LAN. The REST API is the component which communicates directly to the server database, and the current application accompanies another utility called agent. Now these agents are going to be installed on the clients which are represented here, and they actually represent Windows machines in a LAN-based environment. So these agents will be responsible for communicating with the REST API and actually running the backups independently. However, at the same time, the agents will also perform verbose logging using the REST API to the server database. And the backups themselves would run to and from the network shares. So the agents will perform the backup by consuming the given schedules or the configuration, so to speak, to the network shares specified. Next is a very short description of the schema which is involved in building the application. So these are basically the database entities. The first is, of course, the backup configuration itself, and the second is the user, then the activity, which would represent the activity log from the agents, and then the source info, which essentially means the source directories on the agents or on the client machines that are supposed to be backed up to the network share. Next is a very short description of the API, in which for brevity I've just omitted the other details about the activities or users or source info for that matter, and this one just comprises of the configuration itself and the client agent. So the configuration comprises of the crude endpoints, enable disable endpoints. Client agent API is responsible for registering a client, logging the activity, updating or configuring the scheduler, and updating, configuring the scheduler is not a part of the client agent API, it's a part of the client itself. Let me just remove that from here, and this one too. So this also involves other small endpoints, for example, fetching the client agents too, but that has been omitted here for brevity. Next one, I would like to explain a little bit about the algorithm that is involved in the execution of the client agent itself. So there are two ways actually how the client utility could be run. First is with the use of the install switch, and second without the switch. Now there are very specific instances how and when these switches will be used. So the install switch, or the install argument for that matter, is supposed to be used only when an agent is going to be installed on a new computer system in a LAN. So the install will be responsible for registering the client at the server. So it will first verify the server availability and then register the client. And based on the information received from the server that the client is already registered, it will simply fetch the config. It will fetch the config and update the scheduler. If it's not registered, it will configure the scheduler for a 60-minute probe interval. However, if the utility is used without the switch, which is what the scheduler will fire, it will contact the server, get the config. If no config is found, it will reset the scheduler to a 60-minute probe interval. Otherwise, if the config, however, this I've changed it to simple difference between the config and scheduler time. So if the config time received from the server is less than the current scheduler time, it will update the scheduler and run the backup. Because if somebody has configured the backup to an earlier time and the time on the scheduler is later than that, that means that the time configured for the backup has already passed. And in that scenario, the backup should be run immediately. And that's what exactly the agent is doing over here. However, if the time received from the server for the config is greater than the currently scheduled time in the scheduler, it will simply configure the scheduler, or in other words, update the scheduler to the later time, so that the scheduler will itself fire the backup when that time comes. Otherwise, it will simply run the normal backup. And we will see this algorithm in action shortly, so we don't really have to spend a lot of time here. Proceeding, let me just close this down. So let's extract the zipped file over here. and have a quick look at the solutions. So like I said, we have two main components. First is the agent, and second is the main web utility. Now in this solution, I have kept both the front end, as in the ASP.NET hosting of the front end, and the web API on the same domain, or in other words, in the same solution. So let me open the solution real quick. So let me quickly walk you through the solution architecture and design before we proceed. So here we can see that the solution follows a n-tier architecture in which we have clear segregation and separation of the components in the different parts of the solution. The first one is let me start from here, is the model, which contains the database entities that we looked at before in the ATLD document. And then we have the data layer. Then we have the domain layer, which contains all the business logic. And then we have the front end, or the web application itself. So before proceeding, let me start with the model project. So here we can see that we have the entities. We have the backup configuration model. Let's have a quick look at that. So in this, we are actually following the entity framework code first, and this represents a POCO, or a plain old CLR object, in other words. So this model has been created similar to what we discussed before, which represents the backup configuration entity in the application. The other entities are similarly created as POCOs for the entity framework. We have the client. So when a client registers, it's going to be registered using this model in the database. We have the source information, which contains information about the source paths. It has navigational properties to the backup configuration, which represent foreign keys. And then we have user model. So there's nothing more to the model project itself. Let's proceed to the data layer. In the data layer, we are following the repository pattern. So the repository pattern goes very well with any kind of ORM, and it really complements the use of entity framework in this project. So here we have the repositories. We have the context, which represents the database itself. We have the repository initializer, which we'll look at very shortly. It's responsible for firing the seed on first application load. So our database is populated with some initial data to work with. Then we have clear separation of concerns by using abstraction in the form of interfaces for the repositories. We have concrete implementations for the associated or the respective repositories here. For example, we can see that there is, we have a base repository which has the common generic functions related to a data layer, and then other repositories implement this. For example, if I look at the backup configuration repository, so these individual repositories have specific fields or members that are responsible for performing some specific tasks. For example, getting the backup configuration by IP, etc. In the repositories, we also follow the unit of work pattern, which encapsulates all the changes to the database context in a single session. And this is managed through the per-resolve lifetime manager of Unity, which we'll talk about pretty shortly. Alrighty. Then we also have something called migrations, which is code-first migrations, which are enabled in case you want to have or you want to make some updates to the schema, and then later on automatically update the database. We can simply use the migrations and perform commands like add migrations or update database to actually update the database in case of a change to the schema of the model or the POCOs that we looked at before. Here, let me quickly also point to the configuration file. Alright, these errors, it's just displaying these errors because I have not built the solution yet, so maybe it's not following the NuGet references as yet. But let me just quickly point out the seed method here, which is what is called by the repository initializer when the application is first loaded. So the seed method currently just creates two test users. First, the admin with the admin rights, and the second as a normal user without the admin rights, so that when we first run our application, we are at least able to log into it using the test admin, because we have some role-based functionalities in the app which will not be available unless we are logged in as an admin. So proceeding, we have the domain layer. Now this is partially following the DDD or the domain-driven design model, wherein we design our domain around the functionalities required by the application. So here also we see a similar pattern of abstraction, which again enables clear separation of concerns. The domain is totally agnostic. This project, like others, is totally agnostic of the concrete implementations of the types in the other projects. So this is mainly concerned with the interfaces in the data layer and not the concrete implementations of those interfaces there. So if we have a quick look at the concrete classes, we have, for example, Backup Configuration Manager, which is responsible for all the tasks pertaining to the backup configuration, which will be used by the WebAPI or any other client for that matter, or a consumer of this library. So for example, we have we can have a look at that in the abstract definition of this, the interface. So for example, we get backup configuration by IP, get all, delete, enable or disable backup, and upsert. So upsert is basically, it either inserts or updates the backup configuration entity depending on whether or not it's already present in the database. So proceeding, before proceeding, let me quickly also point to the validations which I put in here. So here are the validators. There are a lot of validations.